Hi, everyone. Welcome back. We're going to continue our discussion of Chapter 6 now with hurricanes. So this is Part 2B, hurricanes. So first of all, the definition. A hurricane is a storm of the tropics with sustained winds over 74 miles an hour. Now, of course, they can go much faster than that, but they have to have speeds over 74 miles per hour in order to be considered a hurricane. Now, we use the word hurricane in the North Atlantic. We also use it in the eastern portion of the Pacific. But as we get towards other parts of the world, like the Western Pacific and the Indian Ocean, we're going to use other terms like tropical cyclone or typhoon. They're exactly the same thing, just different name for the different location. So they all have intense low pressure centers, usually, let's say, somewhere around 800 to 900 millibars, so pretty low by comparison to our standard 1013 millibars. And unlike the tornadoes that we just discussed, hurricanes, instead of being 100 to 600 feet across, a typical hurricane would be 100 to 600 miles across, so 5,000 times bigger. Now, with a hurricane, we also get strong winds, as just mentioned, 74 plus miles an hour, all the way to just over 200 miles an hour is the strongest ever recorded. But we'll see in a little while, that is not the danger of a hurricane. Whereas a tornado, the debris inside the moving air was the issue of concern. For a hurricane, it's actually water. Again, we're going to see this again in just a second. So the structure of a hurricane we're going to look at in just a second. We're going to look at the structure in terms of the eye wall, the spiral wind bands or rain bands coming in, and let's get right into that now. First of all, the location. Hurricanes need warm water, so they have to be over warm tropical waters, usually over 80 degrees Fahrenheit. Now, we also need to make sure that as a storm develops, it grows like a thunderstorm growing. We can't have the top of it chopped off by upper level winds. We call that wind shear. So it has to be an area without wind shear. So where we typically get this is about 5 degrees north to 25 degrees north and 5 degrees south to 25 degrees south. Another component we need is for the air to spin. So we have to have enough Coriolis force to allow a storm to spin. So you'll notice here, we don't get any hurricanes forming from 5 degrees north to 5 degrees south. So right around the equator, not enough Coriolis force, and therefore no hurricanes. Now, the warmer the water, the greater the chance of a hurricane forming. So even though we get them from 5 to 25 degrees north and 5 to 25 degrees south, the great majority are going to form slightly closer, but not at, again, closer to the equator, 5 to 15 degrees north and 5 to 15 degrees south. They, again, will not form right around the equator. For the Northern Hemisphere, where we live, our season will go from June 1st through November 30th. So that is a typical hurricane season. So if we're looking at the Atlantic hurricane season, those that affect Florida, the Carolinas, etc., we're looking at June through November with a peak in the fall when the ocean temperatures are the warmest nearby. So basically, September will probably be the peak in the Northern Hemisphere. Okay? 80% of them, August to October, peak in September. So here's a diagram of where we find hurricanes. The orange is showing where they typically form. So we get them not at the equator, but just north and just south of the equator. Now we'll notice in the southern hemisphere, because of wind shear and other factors with the water and the water being driven by the shape of South America, slightly more warm water coming up towards the north here. That's going to make this area in the Caribbean very, very, very warm and very conducive to hurricanes in the fall. So the orange areas where they form, and as you see around the equator, hurricanes are not forming at all. So in the northern hemisphere Atlantic, we call them hurricanes. There are few, if any. There's only one I've ever heard of in the South Atlantic. In the in the eastern portion of the Pacific, out here off the coast of Mexico, we will get the name hurricanes also. In the Indian Ocean, tropical cyclones, and in the Pacific, in the western portion of the Pacific, we refer to them as typhoons. Same thing, different location. And by the way, the typhoons can be the strongest on the planet because the Pacific Ocean is the largest ocean on the planet, and as the typhoons start to form, they're over warmer water for a longer period of time. Again, just another way of looking at this, hurricane locations, we don't get any right by the equator. So what do we need? Water temperatures over 80 degrees Fahrenheit. That's the fuel for the hurricane. Basically, water vapor evaporating into the air, releasing latent heat. That's going to make that air warmer than the air around it. It wants to grow. It's going to pull air in from all around. And that air that's being pulled in and upwards is going to release more latent heat. So if the ingredients are right, warm water, no upper level wind shear, staying over water, not over the land, but staying over the water, the fuel continues to be there as a source to allow the hurricane to grow. So from what? We'll see in just a second. So all hurricanes begin as something called an easterly wave or a tropical disturbance. So a tropical disturbance or easterly wave, usually for the Atlantic, they will form off the coast of Africa. This is the African coastline right here. And in this lower diagram, also, here's the western coast of Africa. So thunderstorms developing on the land move from the east towards the west. So we call them easterly waves because they're coming from the east, move over water. So we get lines of thunderstorms moving over the water. Now they're going to suck air up. That moisture is going to be released from water vapor into condensed water, release that latent heat, and allow that system to keep growing and growing and growing. So an easterly wave is basically a baby hurricane, but it's at this point has sustained winds under 23 miles an hour. As the system continues to move from the east over towards the west, over warm water, it will grow and grow and grow. So the sequence is from an easterly wave, winds under 23 miles per hour. If those winds exceed 23 miles an hour, we now change the name to a tropical depression. So a tropical depression will typically get a number so we can identify the specific tropical depression as it continues its march from east to west across the tropical ocean here, in this case the Atlantic. If it stays over warm water, it will continue to grow and it will continue to spin at this point. So as it spins, it can pull air in from further and further and further afield. If the wind speeds, sustained winds, that means that they're going to be blowing for more than a minute continuously at the speeds of 39 miles per hour or greater, we now call this a tropical storm. So tropical storms are storms of the tropics over the oceans with sustained winds over 39 miles per hour. At that point, we give it a name, by the way. So all tropical storms will get names. And the first tropical storm of the season will get a name beginning with the letter A. The second one with the letter B. And by the way, if the A name was female, the B will be male, and it will go back and forth and back and forth. And then the following year, by the way, in year 2, the A name will be a male name, and then the B name will be a female name. So it's quite a lot of gender equity here in terms of the naming. So storms get their name at this point when they become a tropical storm, and I'll show you a list of that in just a little bit. If that tropical storm moves over cold water, it will die down. If it moves over land, it will die down. But if it stays over warm ocean water, it will continue to grow. And if it grows enough and spins enough to pull more and more moist air in, so that air goes upwards and condenses, it will form a hurricane when winds exceed 74 miles per hour on a sustained basis. It can't just be a gust, it has to be sustained for over a minute at over 74 miles per hour. And if that hurricane stays over warm ocean water and continues to grow and pull more moist air in, grow, wind speeds get faster, we'll go from the first category, the ones that are just over 74 miles an hour, to a category 2, 3, 4, or category 5 hurricane. So all of this sequence is important. So all hurricanes were once tropical storms. All tropical storms were once tropical depressions, and all tropical depressions were once easterly waves. But not every easterly wave will develop into a tropical storm or a hurricane. For that matter, all tropical storms don't become hurricanes. The ones that do will change their name from tropical storm, letter beginning or name beginning with the letter A, to hurricane with that same name. Here's our typical pattern of our easterly waves developing into tropical storms ultimately, and then hurricanes, and taking a path like so. So this is the path that hurricanes have taken from 1851 to 2016. So basically, they move from the east towards the west. Then they will follow the ocean currents, moving along the east coast of the U.S. They'll start to move towards the north, and then they'll move off towards the northeast and will die off at some point. Once the water gets cold enough, or there's upper level wind shear, or they go over land, they will die away. So again, a very typical path from the east towards the west, then they start heading north, and then they start heading towards the northeast. Now, the cross-section of a hurricane, a typical hurricane, would look like this. So we have basically moist air coming in these spiral rain bands, moving counterclockwise, and as they get closer and closer to the eye, they get faster and faster and faster and faster and faster and faster as the air is also moving up. The strongest winds will be along the edge of the eye, the place we call the eye wall. So here's the eye wall, and this is the eye. And within the eye, air is actually sinking down, so there's no cloud cover there. So many times people have experienced hurricanes with the winds getting stronger and stronger and stronger, and all of a sudden they think the hurricane is past, but they're instead in the eye, and the trailing eye wall will be soon to follow. We can see this from space, spiral bands coming in. This is northern hemisphere, rotating counterclockwise all the way to the eye wall with the strongest winds, and then the eye right here. In a Doppler radar cross section, we would see the eye right here, clear skies, and the most intense wind and rain at the eye wall. So we talked about the track going to the west, then to the north, and then to the northeast. We typically talk about winds, the direction they come from, but in this case I wanted to highlight, and I'm talking the direction that they're going to. Now, the thing that is most deadly with hurricanes is not the winds, but it is something called storm surge. It's basically with the low pressure and the rotating air going around and around, pushing a big ball of water in front of it. That can add to the regular level of the tide by sometimes over 25 feet with huge waves on top of that. So basically, most people that die in a hurricane die from drowning. 90% of all deaths in a hurricane are from drowning. Timing of Atlantic hurricanes is going from our season starting typically June 1st all the way till November 30th around here. So our season, again, June 1st through November 30th. And what this diagram is showing you in the red is the number of tropical storms, and in the yellow, the number of hurricanes. Remember, there's always going to be more tropical storms than there are hurricanes because every hurricane was a tropical storm at some point. So we clearly see here where the main period of hurricane development would be, and that is in September. So August, September, October, those are the times when you would expect to get the Atlantic hurricanes. It's also probably the time you would get the cheapest cruise in the Caribbean, and now you know why. Now, hurricane names, they get their names from the tropical storm that they were developed from. And we can see here for 2019, A, B, C, D, E, F, etc. For 2020, Arthur begins with A, Bertha with B. So we have male, female, male, female, male, female names. As we are here towards the end of July 2020, we've had 1, 2, 3, 4, 5, 6, 7. We're on our 1, 2, 3, 4, 5, 6, 7, 8th tropical storm, and Hannah is the first of those to have developed into a hurricane. So Hurricane Hannah developed in late July 2020, and that was again 1, 2, 3, 4, 5, 6, 7. Well, if I could only count 1, 2, 3, 4, 5, 6, 7, 8. So the 8th storm of the season. How far we're going to go, we don't know, but we're only into July. We haven't even hit the peak yet, so it could be quite a stellar year for tropical storms and Atlantic hurricanes. Modern forecasting, well, we use not only satellite imagery, but also we use radar, and we also have airplanes that will fly through to get characteristics of each individual storm. So we can get data from the satellites and from these airplanes, and also from land-based observations as they pass over or near islands, and plug that information into computers, which will model where those storms are going to, whether they will grow, intensify, or die down. As a storm approaches, of course, we've got to do some planning to make sure that we get people evacuated from the potential paths of these quite often devastating storms. I mentioned very early on that we have different categories from category 1 to category 5. So category 1 is just at the threshold of over 74 miles per hour, and these are dangerous enough storms. But as we get to category 2, 3, 4, 5, where the wind speed's increasing, we can see catastrophic damage as these storms come ashore to coastal communities. And remember, 90% of all deaths from hurricanes are from drowning. So the key is get away from the water, get away from the storm surge. Again, it can be over 25 feet. It's almost like a wall, almost like a tsunami coming ashore with the amount of damage it can do. So again, water is the key hazard when it comes to hurricanes. As you can see, I'm reiterating this. That means there's almost definitely going to be a test question on what to watch out for when dealing with a hurricane. All right, folks, thank you very much. Moving on, we are getting towards the end of this chapter. We still have thunderstorms and then a phenomenon called El Nino, La Nina, or ENSO to deal with, and that will be in section 3. Hopefully you learned a little bit here about hurricanes, so let me know in class if you have any questions at all. Thank you. Bye-bye.